This is one of the most iconic distortion pedals ever made, the Boss DS1. But what if we stripped away the enclosure, the branding, and rebuilt it from just the schematic? No PCB, no shortcuts, just raw components on a breadboard. In this video, I'm taking the original DS1 circuit and rebuilding it piece by piece, so we can actually see how it works, not just hear it. And of course, we'll plug it in and see how close the breadboard build gets to the real thing. Now, let's get on to the build. Welcome back to another breadboard tutorial, and today we are going to be recreating the Boss DS1 Distortion circuit. We have 6 stages and a lot of components, so let's just get started. And as always, we're going to be starting with our power supply section right here. If you followed along before, this isn't a very involved power supply. We just have a voltage divider, a diode used for reverse polarity protection, and then a couple of capacitors that will stabilize our power supply. So let's get started. I'm going to start by grabbing my 1N4004 diode, and that's going to just be placed across our power rail, making sure that the little stripe is going to be going into our power, and then the side without the stripe is going to be going into our ground. And you can put this really anywhere in the power and ground rails. The next thing that I'm going to do is grab a 100 UF electrolytic capacitor. Electrolytic capacitors are polarized, so that means one leg is positive and one leg is negative. We can identify the negative leg because it is always shorter, and we also have this little graphic right here. So we want to put the positive leg in the positive rail and the negative leg in the negative rail, something like that. Almost done with the power supply section at this point. Now let's grab two 10K resistors, and again, this is going to be creating a voltage divider. So one leg is going to be in ground. And then we grab another 10K resistor, and then putting this leg in the same row as the other one, this leg, or this one, is going to be connected to the 9-volt power. So by using two equal value resistors, we essentially cut the voltage in half in this row. So we're going to be supplying 9 volts to our power. In this row, it's going to give us 4.5 volts. And then finally, we have to stabilize this power with another electrolytic capacitor. This one is for 47 UF. And just like before, we want to make sure that the negative leg is in the negative rail of our power supply. So we can see right here, we have the little graphic indicating that that is the negative leg. So just referring back to our schematic, we have our diode right here, our 100 UF cap, our voltage divider using our 10K resistors, and then finally our 47 UF cap right here to stabilize our 4.5 volts. So we just finished our power supply, and I'm going to work left to right. So we're going to get started on this input buffer next. My guitar input comes in from right here, so I'm going to start building our input buffer in this section of our breadboard, and that is started with a 1K resistor. So I'm simply going to put a 1K resistor in my breadboard like this, and then eventually the guitar signal will be coming into this leg right here. The next thing that I'm going to do is put a 47 nanofarad capacitor in series, and that can look something just like that. So these legs are now touching each other, and the signal is going to be flowing through this resistor, through this capacitor. The next thing that I have to do is hook up a 470K resistor to our 4.5 volt virtual ground right here. So taking a look at the schematic again, we have our 1K resistor, 47 nanofarad capacitor. Here's that 470K resistor I just talked about, and all of that is going to be going into the base of our transistor right here. So I'm going to go ahead and put the transistor into our breadboard first, and then I'll make this connection just so we know where we have to land this resistor. So here's my transistor here. I am using a 2SC1815 transistor, and the pinout for this is a little bit different than your normal NPN transistors. How this one works is going from left to right, we have our emitter, the middle leg is our collector, and this right leg is our base. So if you're following along and you're not using this specific transistor, just double check your pinout because that will determine if your circuit's going to work or not. So like I just said, this right leg is our base, and I know that our cap right here is connected to it, so I'm going to go throw this into our breadboard right now. So I have our transistor in our breadboard, and like I just said, this leg of our cap is now connected to the base of our transistor, and we can see based on the schematic we have made that connection right there. So now let's create this connection between the 470k resistor to the base of our transistor, and then the other leg is going to be connected to our 4.5 volt virtual ground. So my 470k resistor right here, I'll just drop it into our breadboard like that, kind of stretching it across. And then now I'm going to connect some jumpers to our virtual ground right here, our 4.5 volts, because I know we're going to have to use a lot of references to this, and I need more than just 2 pins. So I'm going to create a couple jumper connections right now that I'll probably have to revisit later in the build. So I'm going to make one connection, jumping it down to this row in the bottom section of our breadboard. I'm going to make another connection, just jumping it into another row right next to it. And then finally, I'm going to make the connection to our 470k resistor. All right, so now we have the 4.5 volts going into this row, getting jumped over to the row with the resistor right here, going to the base of our transistor. The last thing that we have to do for our input buffer is connect our collector to 9 volts and then a 10k resistor going to ground. I have my 10k resistor right here, and then it's the emitter leg that goes to ground, so it's going to be this leftmost leg right here. So I'm going to find that row and then just connect it to ground like that. And then I'm going to use a jumper and connect our collector leg, which is our middle leg, straight to our power rail. All right, so that's our 9 volt jumper going straight to our middle leg, which in our case is our collector. Perfect, we're moving right along. So that's our input buffer done. Now we're going to work on this transistor booster, and this is going to be amplifying our guitar signal significantly before we're going into our op amp gain stage. So the first component that we have to add for this stage is a 0.47 UF capacitor, and that's going to be coming off of our emitter leg. So our next connection is going to be coming off of our emitter leg right here. So I'm going to put our transistor booster stage down in this section right here. And I'm going to use our 0.47 UF cap and just jump it down here into this row right here. The next thing that I have to add is a 100k resistor connected to this leg right here in this row of our capacitor. And then the other side of that resistor is going to be connected to our virtual ground right here. So actually what I'm going to do is, because our virtual ground is over here, I'm going to move this a little bit closer to our virtual ground. So that will make that connection a little bit easier. So here's my 100k resistor. And like I just mentioned, it's going to be connected to our 4.5 volts. And then the other leg is going to be touching this side of our capacitor. In series with our 0.47 UF capacitor, we have a 47 nanofarad capacitor. So I'm going to add that to the breadboard now, just like that. So coming off of this leg of our 0.47 U capacitor, we have a 47 nanofarad capacitor, making sure that this leg is in a row where there's no other connections yet. So the next thing that we're going to add is our transistor here, and that's going to help me figure out where to make all of these other connections. I'm using the same transistor I was in the input buffer section, so it has the same pinout. So based on the schematic, this 47 nanofarad capacitor is touching the base of our transistor. So I'm going to drop this into our breadboard like that, making sure that this capacitor is going into the base, which is our rightmost leg. Also touching the base of our transistor, we have this 100k resistor going to ground, and then coming off of the emitter, we have a 22 ohm resistor going to ground. So here's my 100k resistor. Coming off of the base is going to be going to ground. Coming off of the emitter, we have a 22 ohm resistor going to ground. So both of these resistors are going to ground. This one is connected to the base, 100k. This one connected to our emitter leg is a 22 ohm going to ground as well. The next thing that we're going to do is connect a 470K resistor across our collector and base, as well as a 250 picofarad capacitor across our collector and base as well. It's already getting a little bit crowded down here, so I'm going to use a couple jumper wires to give us a little bit cleaner layout. Okay, so I've just gone ahead and added these two jumper wires. One is connected to our collector and then jumps it into this row. And the other one is connected to our base and it jumps it into this new row. And I made sure that there's no other connections in these rows currently. I know it's close to our virtual ground, but it's not connected there. So now I can hook up our 470K resistor and our 250 picofarad capacitor in these rows right here, giving us a little bit more breathing room on our breadboard. So here's my 470K resistor, just placing it across those two jumper wires like that. And then my 250 picofarad capacitor will go in between those two jumpers as well, just like that. So now the last connection that we need to make is a 10K resistor connected to our positive 9 volts, and that goes into our collector. So we can see right here, our collector is that middle leg, and all I'm gonna do is drop a 10K resistor right into that row where the collector is. All right, so far so good. The next thing that I'm going to do is actually drop our op amp into our breadboard, and that's going to help us figure out where we need to make all of the connections for our op amp gain stage. Go ahead and drop my op amp into the breadboard. I think somewhere like that will probably work. So the next thing I'm going to do is coming off of our collector leg of our transistor booster, I'm going to add a 60 nanofarad capacitor. So if we can recall, we can use one of these jumpers right here that is connected to our collector, which is this one right there. So if I can find an open spot, there are a lot of components to this build. So I just found an open row or an open spot in that row where that jumper is connecting to the collector of our transistor that we used for the boost stage. So we just made that 68 nanofarad capacitor connection right there. And now we have to connect another 100K resistor coming from our 4.5 volt virtual ground. So lucky for us, our virtual ground reference is right next to us. So we can just connect a 100K resistor to this leg of our capacitor right here. So this row right here where that blue jumper is our 4.5 volt reference. So I'm just going to connect a 100K resistor like this, where this leg is in the row where the 4.5 volt reference is, and this leg is touching the left leg of our 68 nanofarad capacitor. The next thing I'm going to do is add a 47K resistor in series with the 68 nanofarad capacitor, and that is going to be going into our non-inverting stage of our op amp A, and that is going to be pin number 3. I'm actually going to move my op amp over just a tiny bit so I can try to reach our resistor into our pin number 3. Starting in this row where that 68 nanofarad left leg is, I'm going to drop my 47K resistor into pin number 3 of our op amp. And before I forget, I'm going to connect our op amp to power, which is our pin number 8. And ground, which is our pin number 4. And I'm going to move this 100 UF cap over just a tiny bit, just so I have a straight shot to our ground rail up here. So just double checking that our rows are correct. Yep, pin number 4 goes to ground and pin number 8 goes to power. The next connection I'm going to make is add this 1N4148 diode connected to pin 3 as well, going to ground, ensuring that the side with the little black line is not going into the ground rail. So that'll look something like that, where the black line is on the side touching pin 3, not the side going to ground. We've already connected our 9 volts and our ground. The next thing that we're going to do is tie our inverting pin to our output pin. So we're going to tie pin number 2 and pin number 1 together using this jumper wire right here. I can just simply put that across pins number 1 and 2. And then the next connection I have to make is connecting pin number 1 into our second op amp stage non-inverting input, which is our pin number 5. I'm going to use a jumper to connect from pin number 1 and then jump across the op amp into pin number 5. Just like that. So coming out of pin number 1, I'm going into pin number 5. The next thing that I'm going to do is add my distortion potentiometer, which is a 100K, to the breadboard, and then we can start working on making these connections right here for our gain potentiometer. So that's going to be a 100K potentiometer. So I'll just drop that into my breadboard somewhere right there next to our op amp. And coming out of our inverting pin of our second op amp stage, which is going to be our pin number 6, we have a 100K resistor going to the wiper lug of our distortion potentiometer. And then we also have this 100 picofarad capacitor coming from pin 7 to the wiper lug of our distortion potentiometer. So let's hook that up right now. So coming out of pin number 6, we're going to hook up this 100K resistor coming from pin 6 going into our middle lug or wiper lug of our potentiometer right here. And then we also are going to connect this 100 picofarad capacitor between pins number 7, which is our output pin of our second op amp stage, connected to our wiper lug of our distortion potentiometer as well. So connecting to pin number 7 and then our wiper lug of our capacitor connected like that. We can also see that our lug number 3 of our distortion potentiometer is touching our output pin. So I'm going to use a jumper to do that as well. So we have here our lug number 3 is connected to our pin number 7 of our op amp. The next thing that I'm going to do is hook up our 4.7K resistor in series with our 0.47U capacitor, and then that will be going to ground. So coming off of our lug number 1 right here, we have our 4.7K resistor, and then I'm going to connect our 0.47UF cap, making sure that the negative leg ends up in our ground rail right there. So they are touching right there, and then this resistor is connected to our lug number 1. So that is our distortion potentiometer all wired up. The next thing that I'm going to do is add this 2.2K resistor coming out of pin number 7 and then a 0.47 UF capacitor in series. So here's my 2.2K resistor, and I'm going to jump it back up into this section right here of our breadboard just because we'll have a little bit more room to work. So coming out of pin number 7 right there, I'm going to drop one leg of my 2.2K resistor, and then I just dropped it up here into this new row where there's no existing connections. And then I'm going to add my 0.47 UF cap, making sure that the positive leg is touching this leg in this row right here. And then I can drop the negative leg into a new row. I'm going to move this all the way up to the top because we're going to have a lot of connections connecting to this row right here. So the last thing that we have to do for our op amp gain stage is connect these clipping diodes to our 4.5 volt virtual ground and then add this 0.01 or 100 nanofarad capacitor to ground. So we have two 1N4148 diodes that will be connected straight to ground. So one of them is going to be with the black line in this row. And then the other one is going to be black line in the ground rail. So this is what's going to give us our symmetrical clipping. The last thing that I have to do is connect a 100 nanofarad capacitor to ground coming off of our row right here as well. So just like that, we have our 100 nanofarad capacitor in that same row going to ground as well. So that's it for our op amp gain stage, and we're going to move right along to our tone and level section. And I'm going to start by putting our tone knob or our tone potentiometer down here in our breadboard somewhere. And our tone knob is a 20K potentiometer. So our first connection we're going to make is coming off of this same row right here where we have our clipping diodes and our 100 nanofarad capacitor to ground. I'm going to hook up a 0.022 UF or 22 nanofarad capacitor and a 2.2K resistor in series going into our lug number 3 of our tone potentiometer. So I'm going to take this jumper wire down here. I'm actually going to jump that row down here because I have to make a couple connections coming off of this for this section. So I'm going to take my 22 nanofarad capacitor and I'll just drop it in a row like that where it's not connected to anything else. And then I need to take my 2.2K resistor, and then this is going to be connected to our lug number 3 of our tone potentiometer. So these legs are touching each other, and then this leg of our 2.2K resistor is touching our lug number 3. Also coming off of our lug number 3, I have this 6.8K resistor that is going to be going to our 4.5 volt virtual ground. So I'm going to drop it over here. And what I'm going to do is actually take a jumper, and from over here where we have our 4.5 volt virtual ground, I can use either this row or this row to get our 4.5 volt reference, and I'm just going to jump it over here into this section. So coming off of this row right here where I have that little jumper, I'm just going to jump this over here and connect it to this leg of our 68K resistor, which is touching our lug number 3. So I've just made this connection right here. So the 4.5 volt reference goes through our 6.8K resistor into our lug number 3 of our tone potentiometer right here. The next thing that I'm going to do is coming off of our jumper row right here, I'm going to add another 6.8K resistor to lug number 1 of our tone potentiometer. So coming out of this row right here, where I have that jumper touching this row, I'm going to add this 6.8K resistor into our lug number 1, just like that. Next, I'm going to hook up this 0.1 UF capacitor coming off of lug number 1 as well, and this is also going to our 4.5 volt virtual ground. So connected to lug 1, I'm going to take this capacitor and stretch it across our potentiometer like that. So this leg connected to lug 1, and then this leg is going to be connected to our 4.5 volt virtual ground reference right here. So the next thing that I'm going to do for this section is coming off of our wiper lug of our tone potentiometer, we're going to be going into our lug number 3 of our level potentiometer, which is 100K. So I'm going to drop our level potentiometer up here. So coming off of our lug number 2 or our wiper lug of our tone potentiometer, we're going to go straight into our lug number 3 right here. So using this jumper wire right here, I can connect straight from our wiper lug into our lug number 3 of our volume potentiometer. And the last thing that we have to do for this section is coming off of our wiper lug of our level, I'm going to add this 10K resistor, and then our lug number 1 is going to be connected to our 4.5 volt virtual ground as well. So I'm going to do just a tiny little bit of rearranging right here for our 4.5 volt reference. I'm just going to move our jumper down one row and the 6.8K resistor down one row, so I can add this jumper going up to the top of our breadboard section right here, because we're going to need that 4.5 volt reference for our next section. And then, like I mentioned, the last component that we have to add is a 10K resistor coming off of our wiper lug right here. We're on the home stretch now. We're just going to work on this output buffer, and then we can go ahead and test our circuit. So I've just put this 10K resistor in the last section, and the next thing that we're going to do is hook up this 1 meg resistor connected to this leg of our 10K resistor, and then the other side of that 1 meg resistor is going to be connected to our 4.5 volt virtual ground right here. So here's one meg resistor connected to our 4.5 volt virtual ground, and the other leg is connected to this left leg of our 10K resistor. I'm then going to add this 47 nanofarad or 0.047 UF capacitor in series with the 10K resistor. So it'll look something like that, where these legs are touching each other. And then on the other side of our capacitor, we have another 1 meg resistor connected to our 4.5 volt virtual ground. just like that. So this leg is connected to our virtual ground, and then this leg is touching our capacitor right here. We can see that these connections are going into the base of our final transistor. So I'm going to add that to the breadboard now. So just like the other sections, this transistor's base is this rightmost leg. So I just put that in the same row where these previous connections were already made. We now can connect our emitter leg to ground through a 10K resistor and our collector leg straight to 9 volts. So if you remember, this is our emitter leg right here, our leftmost leg. So we can connect that to ground through this 10K resistor. And then I connect our collector or our middle leg straight to our 9 volt power. There we go. Just made those connections. Coming off of our emitter leg, we have a 1K resistor and a 1U capacitor. So I'm just gonna jump across one final time where I have this 1K resistor coming off of the collector, this 1U capacitor in series. So these legs are in the same row, and I just dropped this new leg into a new row, making sure that this is the positive leg and this is the negative leg. And then the final connection that we have to make is connecting this 100K resistor to ground. And this resistor will be connected to the negative leg of our capacitor. So now before I forget, I'm going to hook up our guitar input. And it goes into this 1K resistor right here. And then as for our output, it gets connected to this row right here where our capacitor and our 100K resistor are in. So now I'm going to quickly test this circuit, and if I have to make any small changes, I will let you know. So I just got done testing the circuit and I realized I made a couple small mistakes. The first one being I never connected our lug number 1 of our level potentiometer to 4.5 volts. I took care of that by connecting this small jumper wire to our 4.5 volt reference right here. The next thing that I did by mistake was connect our clipping diodes to ground instead of our 4.5 volt reference. So I went ahead and moved our clipping diodes into this new row right here. And then I just used this jumper wire to connect to our 4.5 volt reference. Other than that, I really hope you enjoyed this build of this iconic distortion circuit. As always, if you like content like this, consider subscribing and giving this video a like, and also leave your suggestions for what pedals and circuits I should do next time. Now, I think the only thing left to do is to hear this circuit in action.